In this video, we'll see how to solve one-step inequalities by multiplication or division. So remember, when we're solving an inequality, we're going to use the same method we did as when we are solving equations. The difference is going to be we're going to use the inequality symbol rather than the equal sign, and we will graph our solution. Okay? And our solution that we get, it represents all the possible solutions to this inequality. So when we're solving an equation, we just solved ones where there was one solution to them. But with these inequalities, there will be infinite solutions to them. So when I see this inequality 4m is greater than 80, I want to isolate my variable, and the way I do that is I'm going to divide both sides of this inequality by 4. So 4m divided by 4 is just m, and 80 divided by 4 is 20. So I get m is greater than 20. I want to mark my boundary on my number line now that I graph this. And m is greater than 20, which means m cannot be 20, so I have an open circle. And which numbers are greater than 20? Well, 30 and 40 and 50 and 60, everything to the right of 20 is greater than 20. So I'm going to graph my equation to the right of 20. So what this solution means, m is greater than 20, it means if I substitute 20 or something greater than 20 back into my inequality, so let's choose 21 since that's greater than 20, I should get an answer that's going to be greater than 80. And we can see that 4 times 21 is 84, and that is greater than 80, so it's a solution. However, we have a special case that we have to look out for when we're multiplying and dividing both sides of an inequality by a negative number. So if the coefficient is negative, our inequality symbol is going to switch. So let's take a look at this. H divided by negative 5 is less than or equal to 11. You can see here I've got a negative coefficient. I've got this negative 5. That's negative coefficient. So I know that when I multiply both sides by negative 5 in order to isolate my variable, I am going to switch my inequality symbol. So negative 5 times h over negative 5 is just h. 11 times negative 5 is negative 55. And instead of using the symbol less than or equal to, I'm going to use the symbol greater than or equal to. And that's what I want to graph. H is greater than or equal to a negative 55. So I mark my boundary, negative 55, and h is greater than or equal to negative 55. That means I'm going to have a closed or filled in circle at negative 55. And what numbers are greater than or equal to negative 55? All the numbers to the right of negative 55. And we can check this and see if we're right. If I choose something greater than negative 55, for instance, let's say I choose negative 50, and I substitute that for h. Well, negative 50 divided by negative 5, is that going to be less than or equal to 11? Sure, negative 50 divided by negative 5 is a positive 10, and that's less than or equal to 11. Alright, here is a practice problem for you. When I solve these following inequalities, on which ones will I switch the signs? So remember, the special case is if I multiply or divide both sides by a negative number, I'm going to switch the signs. So I'm just looking for the negative coefficients here. So I'm going to switch the sign on A because the coefficient of x is a negative 2. I wouldn't switch it on B because the coefficient is 1/3, it's positive. C, I wouldn't switch it because the coefficient's positive 2. On D, I would switch it because the coefficient is negative 1/3. E, I would also switch it. The coefficient is negative 6. Alright, solve and graph the inequality 15b is greater than or equal to 150. In order to solve this, I am going to divide both sides by the coefficient 15. 15b over 15 is just b. It's a positive coefficient, so I am not switching the sign. And 150 over 15 is 10. b is greater than or equal to 10. I want to graph my solution. Here's 10. b is greater than or equal to 10, so I'm going to fill in my circle, and everything to the right of 10 is greater than or equal to 10. And finally, negative 27 is less than or equal to negative 3c. Alright, I want to isolate c, so I'm going to divide both sides by negative 3. So negative 3c divided by negative 3 is just c. Negative 27 divided by negative 3 is positive 9. I divided both sides by a negative number, so I need to switch my inequality symbol from a less than or equal to a greater than or equal to. So 9 is greater than or equal to c. I'm going to mark my boundary, 9. I have a greater than or equal to sign, so I'm going to use a filled in circle. Now 9 is greater than or equal to what numbers? Well, it's greater than or equal to 8, 7, 6, 5, all of the numbers that are to the left of it. And that's how we solve and graph one-step inequalities by multiplication and division.